Sure.
you want to kick things off?
Sure. Yeah. So, hey everyone, my name is Jennifer, and I am the marketing community lead here at NuNet. And I'm here to provide a very simplistic overview as to what NuNet is, and then Sam will take it away with a more technical, in-depth view of NuNet. So, NuNet is an open source decentralized platform that's designed to create globally accessible democratized network for computing power. It's a decentralized platform that provides decentralized orchestration layer as well for computing power. So it enables individuals and organizations to share and access distributed compute resources, creating a globally accessible and democratized network for computation. So a very useful analogy for those that kind of get messed up with all those big words is Uber. So if you own a car and have spare time, you can rent out your driving services to other people. This is similar to how individuals or data centers or even certain IoT devices can contribute unused computing power into NuNet's decentralized network. And from the other side, when a rider books an Uber, the platform essentially finds the best match on factors like distance, comfort, vehicle size, if you need an Uber X or an XL. And this is kind of relevant to NuNet's decentralized orchestration layer, which intelligently assigns computational tasks to the most suitable devices within the network. So NuNet's orchestration layer dynamically discovers available devices, evaluates their capabilities, and assigns workloads accordingly, which ensures efficiency, reliability, and scalability across a globally distributed network. Unlike traditional cloud providers that rely on centralized infrastructure, NuNet optimizes the allocation of computational tasks across a peer-to-peer network, which eliminates bottlenecks and hopefully will reduce costs as well. So NuNet was designed to address the limitations of centralized cloud infrastructure, which is also often expensive, restrictive, and controlled by a few large providers or players in the space. And this is especially critical for emerging fields like AI, IoT, and edge computing, where real-time processing and dynamic scalability are essential. And by integrating blockchain and Web3 technologies, NuNet can enable secure, transparent, and automated micropayments, ensuring that contributors are fairly compensated while users gain cost-effective access to decentralized computing resources. And this approach essentially democratizes computing, providing a flexible, scalable, and community-driven alternative to traditional cloud services. So hopefully, Sam can take it away now from the technical side, where I will listen in. You're on mute there, Sam.
Thank you, Jen. So, trying to think about exactly where to start here, but obviously Jen's kind of laid the outline of what it is. This network of just being able to connect loads of stuff together and make it work together. So what I want to do initially, if I just share my screen, let me know if you can see this.
Yep, we can.
Okay, cool. So let's start with something a little more user-friendly than terminal sessions. So if we look at what we can do initially is just kind of look at the differences between NuNet, which is a effectively decentralized public cloud infrastructure, and existing public cloud infrastructure. Then we can kind of get an understanding of the differences and the similarities, right? So kind of if we look at centralized public cloud infrastructure, and by this I'm talking about AWS, Google, etc., They basically have private data centers with very specific hardware, custom operating systems, and everything that runs on top of that is containerized or virtualized. And then generally they will run some local node software that allow various, or as a compute user, you would run some local node software and connect through their private network your local nodes and have some sort of centralized orchestration system that is managing those nodes and where workloads should be deployed, etc., across this private network. And this centralized orchestration system is kind of supported by centralized backend databases where user accounts and all that kind of stuff is stored. And then they have payment gateways in order for you to pay for those services that you're orchestrating on their network. And then they basically have, on top of that, they have this kind of observability and a contract with them, along with some security and some initial identity checks that you have to go through, effectively kind of give them credit card details, etc. And you manage the whole thing through a centralized console. So, you connect to a centralized server and you log into a web console and you use that to manage everything. So if we compare that to how DMS works, just at the kind of the structural level, then NuNet can basically work from individuals, community-run data centers, but it can also run in private data centers or co-located data centers. Basically, can run anywhere, and include everyone. Right? This is the democratizing access part of things. It will pretty much run on anything where Linux can run, which is most things, to be honest. And it can run on, although it runs predominantly in Linux, it will run natively on Mac, and we're working on getting it to run natively in Windows, but we may well find that actually with Windows, virtualization is kind of good enough. And it still uses this same concept of containerization to run the workloads that you want to run. The fundamental difference now is that it's just decentralized node software that's running, which is connecting peer-to-peer. So rather than having a private network, we're using the public internet and peer-to-peer networking protocols to allow the nodes to discover each other and communicate on the network. Then and in fact, this is probably the most fundamental part, is that in the centralized systems, you kind of look to a central part of the network to be able to connect to, and that is going to use the database and security to authorize you and make the orchestration decisions, and that's very, very centralized and requires someone to operate it. The difference with NuNet is that all of that is logical, so it's effectively managed by the software that's running on all the decentralized nodes. The decentralized nodes are making the decisions and talking between themselves in order to decide where the best place to run certain things will be. And then rather than having payment gateways and some traditional stuff, we're obviously blockchain integrated. This bit's a little bit grayed out at the moment because we haven't fully got that sorted, but blockchain and Web3 tech, obviously why most of us are here, which will support the payment layer and also some of the decentralized identity and security that Web3 kind of brings with it. And then the last bit that's kind of also fairly fundamental and key to the decentralized part is you manage it and look after it through a locally hosted machine that you're running, and that could be kind of proxied for you. So there could be multiple providers that aren't NuNet that are running a console that would allow you to manage things on the network. And basically, you know, the kind of compute workloads that we're looking at is for training, fine-tuning, inferencing, and then, but then not just that, but also just database and data management and any other kind of web hosting and middleware like APIs and all that kind of stuff. So that's the kind of overview and comparison between the two. If we kind of just look at the key, some of the key part here is that we have the node, which has a peer ID. So every node on the network has a unique identity. But along with the node's identity, it also has a unique DID, or a decentralized ID, which is the security identifier which all the nodes use. And so these green shields indicate like the security layer where the DMS node can assign and check the capabilities of any other node on the network. And anytime a node on the network talks to another node on the network, it sends not only its DID, but also a token that expresses what it's allowed to do on the network, and machines can grant that access between each other, or look to an organization as a source of authority to decide if something can run or not. And it's not just one organization like NuNet, but multiple organizations can exist and can coexist on the network and provide that level of authority. So that's a brief one. I'm sorry, I'm kind of going quick, just because we've got a lot to get through. But what I kind of wanted to do now is just talk about how we're going to get there. And in fact, before I do that, what I want to do is just show you quickly what DMS looks like. So at the moment, if I want to interact with DMS, it's pretty much all at the command line, right? We are about 9 months away from the full release. And so pretty much all of the functionality we have at the moment is done at a command line. And there's a fairly large set of commands that you can run that allow you to do various things like control or create subnets or allocate things to subnets. Like this is a virtual networking layer that sits on top of the internet connection that allows workloads to talk to each other through their own kind of private network. But then also you can kind of do some deployment stuff. You can create a new deployment. You can check status of deployments. You can onboard your machine, and you can interact with other peers on the network, and you can view the resources that are available or allocated. Okay, so like if I want to check the resources that are onboarded on this machine, well, there might be someone here. I can run a command like that, and it will return some data about there's 3 cores on here with some disk and some RAM. Okay, so the point that I'm trying to make here is, like, at the moment, the way to interact with DMS is fairly complicated and a bit of a barrier to entry for people that aren't really used to working with systems on a command line, or expressing a workload. So I'll give you an example of a workload as well. So if I let's look at a quick workload. So this is a job description where we're basically saying how we want to run it. So we want to use Docker to run it, how many cores it needs, what RAM, disk, what container image to use, and along here, you could specify GPU types and or amounts of VRAM and stuff like that. And then you can also specify things like a region where you would want to deploy it to, or go down to region, country, city, and actually now we're also going down to the point of an ISP. So actually you can target a specific ISP in a specific city. You can also directly specify that you want to run it on a particular peer. If you don't put something like this, or you don't put some of this stuff in, then the job will get submitted to the network, and then the nodes will figure out where the best place for it to run is. Okay. So this is interacting with DMS as it currently stands. We understand that this is a bit of a barrier to entry. So what we're trying to do now is to create an appliance, and let's just start here actually, like in terms of what the appliance is. So the appliance is basically the best practice deployment of an operating system, plus all of the relevant utilities and applications that it needs to reliably run and help you manage and monitor the device that's running. Okay, so we use the container runtime with Docker. We install the DMS, so the NuNet DMS software, which is the orchestration and executor layer, which basically communicates with the other nodes on the network and then tells the Docker instance that's running on this machine what to do. And we have the new actor system, which is basically handling all of the security and access control that's fully decentralized. And then we're so this is the core NuNet product, but we're bundling it together alongside some firewall controls, some additional utilities that allow you to not only manage DMS, but also manage some of the stuff on your machine. Some best practice security practices for when you're running the server and how that kind of works. So, making sure that rather than just deploying it on a server in a very basic way, we're being a little bit selective about how it's deployed so that it's kind of done in the most secure way that we can. Then we also add some monitoring software that will basically monitor the statistics of this machine and basically present it to the person that's running the machine in the form of some analytics so they can understand the performance of the machine and what's going on. And when you get to a hardware appliance like this, and by a hardware appliance, this could basically be any machine that can kind of run Windows or things down to like a Raspberry Pi. We can just plug a USB stick into it and then boot it off the USB stick and create this application that runs natively on the bare metal hardware. And that will support multiple GPU types. I've got NVIDIA here, but it would also support AMD GPUs as well. And it's going to connect through the physical network interface to the rest of to the internet. What we're going to look at today, obviously this requires you to kind of get to the point where you're like, yeah, I'm going to run NuNet and I'm just going to blow away a machine to be a dedicated NuNet node. However, before you get there, may well be that it's not for you, or you just want to kind of run a part-time basis, or you want to access the network to do certain things, but you also want to kind of get on with your other work, etc. In which case you may well want to run it on Windows or on a Mac, and then use a virtual appliance, which basically has all of those tools that we just talked about, but just bundles them together into a virtual machine that will run on top of your existing operating system. And so what we're going to do today is try and go through and install on Windows and show you hopefully how easy it is to get from Windows to joining the NuNet network. So I think from now, I think I'm going to jump into demo mode. So fingers crossed. And I think there's someone else that wants to do an install with me today. So I'm not sure, is that Vasu? Did you say you were going to do that today?
Yeah. I
Okay.
did the install before too. Like we can
Okay.
uninstall it and install it again.
What I'll do is I'm going to stop sharing this screen and then share from my Windows machine. I can also, let's do that. Or in fact, actually, while I'm here, we can see here. I can just kill this. Oh. I can just show you whilst I'm on the Mac. Oh, am I still sharing? Can you still see my screen?
Yeah, we can see a Zoom page.
Okay. Oh, you can see the screen on my. Okay, yeah. Okay, cool. So let me just get onto it with. Okay, so this is my Windows machine. I've actually already downloaded the installer, but you can grab the installer from our GitLab repo. There is under NuNet Solutions, NuNet Appliance. There's a repository. We're currently in.
Yeah.
Sorry.
I think the better way to send this out is through the Google Drive link you sent me.
Okay.
Yeah.
Okay.
Send that link. Yeah.
We can also the latest versions can just be downloaded from here as well. So just to show, you can just click here and then hit the download button, and then you'll get it. Okay. But we'll also send it via Google Drive so people can just share it natively. So let's go through and install. So if we've got the zip file here, we can just right click it. And it's important that you do this, that you extract all the files first rather than just allowing Windows. If you just click in here, then this hasn't been extracted yet, and then it kind of behaves a bit differently. So you need to choose the option to extract the files, and when you do that, it then turns the zip into a folder, and in the folder you have this NuNet Appliance installer. You can just right click on that and you can choose Run as Administrator. You need to run as administrator because it's got a fair amount of stuff to do, like installing various bits of software on your machine. And so because it's an unsigned tool, an unsigned executable, you need to go here and say run anyway. Choose yes. I've had several people have had some problems with it being flagged as a virus. I didn't have any problems with it, and then today I did, and I just had to go into, when it popped up on Avast, which is the antivirus I'm using, I got a screen like this saying that it was this IDP generic, which is kind of, I think, what virus scanners, they don't understand what it is. And I basically just created an exception for it, and I didn't get any more hassle. Okay. So and so we run as administrator, we get this kind of box that pops up that's basically checking all of the operating system and the spec of your machine. And it's basically starting to write a log file so that we have a kind of, you have a record of what it's done. And if there's any issues with it, we can use that for troubleshooting. And we can see here that I'm not sure if you can read it because it might be a bit small, but it's basically saying the following components are missing, which is a Visual C++ redistributable. This is like a Microsoft thing that's required for VirtualBox, which is a virtualization engine that we're going to use, and Multipass, which is a very kind of a user-friendly tool to manage virtual machines without too much bells and whistles. So if we just say yes to install this stuff, basically the installer is going to go away and make it happen. So we can see we installed the redistributable. Now it's getting VirtualBox. While we're kind of waiting for this, has anyone got any questions so far? Is there anything anyone would like me to clarify, or anyone got any other questions?
I do have a question. It's I wasn't able to tell Multipass which drive to use. It seems to default to a drive which for me doesn't have enough space, and this might be a bit niche question. I recognize, but
yes, that is a problem of using a simplified tool. Yeah, I think you're right. It defaults to Windows program data, I think. I actually let me just kick this bit off, and then I'll get back to that question. So now that it's got all of those tools, it's now basically wants to select a network that you want to connect the appliance to. And so on my machine, it's pretty basic because I've only got a Wi-Fi connector in this laptop. But you may have a physical network connection or multiple Wi-Fi connections on your machine. It's important to choose the one here that is the one that you use to connect to the internet as well. And this is going to allow the appliance to connect to the internet on your network, but kind of appear on your network as a different machine properly and not be redirected through the networking of your machine. It's more efficient to do it that way. Okay. So we just select the network, and then you can specify how many CPU cores you want to onboard. Let's do 4. And the amount of RAM. This machine's only got 8 gigs of RAM, so I'll give it 4. And then it says the amount of disk you want to allocate, which is 20 gigs. If you are running this with a view to running workloads for people, then the amount that you really allocate here should be probably at least in the region of 100 gigs of disk space, because quite quickly that can get used up as people are trying to run different images and stuff like that. But from a testing perspective, or if you want to use it just to connect to NuNet and run some stuff on other people's machines, then 20 gigs is fine. Okay, so now we're gonna kick that off, and it's now gonna go off and grab the operating system image that it's gonna use to set up the appliance. So the way this kind of works is it just uses like what we call it, like the vanilla operating system. So vanilla Ubuntu 24.04, and then all of the changes that we make to the operating system are scripted, right? So there's basically, it will download the vanilla operating system, and then it will just run this script to go through and make all of the changes that are required to get you to where we want to be as the fully running appliance. And there's kind of, although it might take a little bit longer to do, what it does is it really provides some transparency about what's going on, right? Like it's not a black box. What NuNet is doing is kind of completely open source, right? And we want to be very transparent about what we're doing, and B, we want people to get involved with this project and kind of modify it to do the things that they want to do, and get involved in discussions with other community members and look at how it's done and propose changes and, you know, the normal open source stuff, because that's pretty important to us. It's pretty important that we kind of make the product that is going to make the most benefit to the most people, and the way to do that is to have everyone involved. So we can see we've pretty much got the image now. If your network connection is not too fast, I think it's about a 2 gig image, so you know it can take a little while to run. And then it should go to the next step of starting to install the operating system and actually running up the virtual machine. While we're waiting for that, let me have a quick look to see here. Because I did go to have a look to see that there's not even anywhere in the Multipass software to specify where you want to put the virtual machines. I think we might still be waiting. I think once the machine starts, we'll see where it arrives. But in order to answer your question about how to handle this, there is a way to handle it. I believe there's a way to handle it, and that is to create something called a mount point. So if you've got another disk in your machine, you've got an E drive or something, you know, another disk, you can basically create a pointer that points to another folder in another disk. So, and as one of our devs that was testing it out had that issue, and I'm working with him to get a kind of a neat solution to be able to fix that and redirect where the stuff's saved. So you can you can specify a larger chunk of data and have that on a separate disk, so it doesn't kind of mess with your day-to-day. We can see here now that it's starting NuNet DMS. And while we're doing this, because I'm kind of aware of time, that whilst this is running, we can probably open the Multipass application. And so this is one of the pieces of software that we installed alongside VirtualBox, and you can see it's pretty basic, but it's basically written by the people that make Ubuntu, which is one of the most popular Linux distributions out there, and it's designed for you to be able to very easily run Ubuntu virtual machines, and actually they make, I think, maybe it's not, that they do create various other appliances like this Mosquitoes and message queuing appliance, It looks like they also have this ad guard. OpenHab is like a smart home, Plex media server. So these are the kind of appliances. We're just building along those lines and creating a decentralized compute appliance. But the key part that I wanted to show you is, whilst this is building, we can see here that we have we can select it. And while this is still running at the moment, so we don't need to go here, but the key part here is we can see the details of the machine. We can see what its IP address is on your network. And you also have, you can see here that the configure button's grayed out. But if you want to make any changes at a later date and modify the resources that you want to onboard, basically you can go to here to actions and then just stop the virtual machine. And when it's stopped, this button won't be grayed out anymore. And it's very simple sliders to just adjust the CPU, memory, and disk allocation. Okay, so and it's literally, there's not really anything else that you can do in terms of controls on this. It's very basic and just very simple. That's what we're trying to achieve here, is just make it to lower the barrier to entry. What I will say, actually, and I'll just jump back to my my other presentation for a moment. So what you will see here, do you see the presentation now?
Yes.
Yeah.
Yes,
Okay,
we can.
cool.
Yep.
Okay, cool. So you can see here we're kind of symbolizing the virtualization layer on top of the machine. And although we're using VirtualBox at the moment, the reason that we're using VirtualBox by default is that that's the virtualization software that any version of Windows can run. If it's Windows Home or Enterprise or whatever, it can run. You need to run VirtualBox. But there's also Windows native virtualization that comes with Windows Pro called Hyper-V. Hyper-V has probably got a bit better performance than VirtualBox, and also has a fundamental additional capability of being able to get pass-through connectivity to GPUs. Okay, so actually the next step for us with this appliance is to provide an option to be able to switch from VirtualBox to Hyper-V, and then create some additional options to be able to partition your GPU and then provide parts of it to the virtual appliance using Hyper-V rather than VirtualBox. And it's still all controlled using this Multipass tool. Multipass will support VirtualBox and Hyper-V. Just that this is a fundamental difference in the virtualization, that we get GPU support. One of the other things that we can just quickly touch on here is, you can see I drew a picture here of a bridged NIC or network interface card, and the physical NIC that's in the machine, and how they're connected to the local network and then to the router and then to the internet. So although when we chose the network adapter, I chose Wi-Fi on mine. It's here. Basically, what that did was, although it's still using the physical network card, it gets a new IP address, which is hiding behind there. But it gets a new IP address on my network. It's a valid IP address on my network. So actually, it doesn't. Although it's using this card, it has its own address on the network. It has its own rules that can then allow you to make additional modifications to the router that will allow it to, you can make optimizations to your router, which allow you to configure access from the internet back to this machine if you want to run like hosting or some other other stuff like that, where you want to have external access from the public internet. So that's that. I'm gonna stop sharing this and jump back to my Windows machine because that has finished. Do you see my Windows?
Yes, we can.
Okay, great. Okay, so you can see we've got this box that's popped up here saying the virtual appliance has been installed. And it just says that you can interact with the appliance in a command, or it actually says the console window will open, giving you access. Actually, I've made a slight change because I realized that wasn't a good long-term solution just to pop it open and then if it disappears, you don't know what to do anymore. So actually, and it says here, you can interact with the appliance in a command prompt window, or you can open the Multipass GUI from your applications to manage the appliance. So obviously, we're looking at the Multipass GUI here. Just click OK on this, and we get a log file that has all the details of the installation. Which, if you have any issues with it, you can share that with people. But more to the point, from the Multipass GUI, we can click here and we can have access to the appliance from here, okay? And so we can just interact with it and use the menu system from here if we like, and we can choose the options to stop it or suspend it or just delete it if we're done with it, right? But there's a second option, because maybe you don't want this kind of clunky interface, that it created a shortcut here for managing the NuNet appliance. So you can double click that and you get this little window here that basically tells you the status of it and its IP address, and gives you stop, start and restart capability, and also fundamentally the option to open the shell, which does basically the same as what you can do from the Multipass GUI, except for the fact that you just don't need to be running that. We can just leave the instances running, close that, and then we can get to the console. So that's it. It's gone through that process of downloading the operating system and then making all of the changes, installing NuNet, installing various bits of software, and it's got to the point now where we can see that Docker is running, DMS is installed, what the version number is, but it's not running yet. And you can see here that we have our DID key, which is our unique security identifier on the network, but we don't have a peer ID yet. We don't have a peer ID yet because we haven't actually started DMS yet. So we can choose to start DMS with option 1. And then we should see that now DMS is running and we have a peer ID on the network, which means we're actually connected to the NuNet network. So you can see here there are various options, and the idea behind this is we kind of remove the complexity of having to know all of those command line commands that I was talking about in the past, that you can just basically logically do the things that you want to do. And we're expecting that the community will just start contributing to this and saying, okay, well, I want this functionality and that functionality, and this menu will just grow into supporting all the things that people want to do, okay? So we can just quickly have a look at the other machines that we're connected to on the network. So by now we've just connected to 3 machines, and we can see here that we've got the round trip times, or the latency between these machines. So actually this one here is another machine on my network, which is why we have a very low latency. And then there's 2 other machines that are somewhere else. Not really sure what they are. And over time, we should just see this list grow as we're organically connecting to different peers on the network and making a list of them till we get to the point where we've built this nice kind of connectivity with the rest of the network. But what's useful here is, you know, if you want to run something on another machine, then maybe you are aware of the response times and stuff like that. So you can quickly see other peers that you might want to be able to schedule a job with. And then using this menu, you can just select one of them and hit enter. And that, although there's not very much data at the moment, like it's only been running for a couple of minutes, you'll get a historical list here of over the last hour what the response has been. So you can kind of gauge, is this a good machine to connect with, and then it will just draw you a graph here. Okay, so that's just the absolute basics of getting connected to the network. Obviously, once you're connected to the network, one of the key things that you're going to want to do probably is to join an organization. You actually don't need to. You could just choose to share your resources with other friends, or whoever, and not have to use any organization, but more fun if you join an organization, I think. So if we go and have a look here, you see, before we do that, there's also this option to run deep in nodes. And what we're kind of aiming for here is to basically partner with lots of other deep in projects that want people to run nodes for them, and kind of help them lower the barrier to entry for people to be able to run nodes, for people to be able to just fire this up, come in here, and then select which type of node they want to run, and then spin it up, go through a process that kind of talks you through whatever the requirements are for that node, and then it kind of captures that information and then uses that to deploy the node for you, or for them. Okay, so that's kind of functionality number 1, enabling multiple deep in projects to lower the barrier to entry to running nodes on their network. Obviously, you join an organization, which we can do now. You can actually, rather than just running something specific, you can join the organization, and by joining the organization will potentially have the rights to run things on your machine on behalf of the organization. So you're kind of giving some trust to the organization you join to be responsible about the types of things they want to run on your machine, and to provide you with the compensation for doing that. So let's join the NuNet testnet, just so you can kind of see how this works. We can go and choose option 1. Do you want to proceed? Say yes. And then it basically just grabs your DID key, and then it's sending your DID key to a machine at the organization, using this decentralized encryption tool called Wormhole. And actually, because it's using this decentralized encryption tool, it's not directly managed or owned by the organization. It is, anyone can do it. So once we have this thing to say connect with another peer on the network, you would be able to give this code to someone else, and they can put it in, and then you'll be able to exchange credentials and they could authorize you could authorize them to run something. So let's just I'm entering this at the other end. Okay, so
There.
right, I've just received that request, and now I'm trying to send the tokens back. So I'm just gonna copy that, paste it in here. Ooh. Demo effect. Sorry about that. That wasn't the smoothest. Let's try again. Okay, I've received the key at my end. Well, that's the demo effect. I haven't had any problems with this. Let's just try one more time. Third time lucky. Okay, there we go. Third time lucky. Literally, this is one of the most stable parts of it, to be honest, and I don't know why that's a bit funny. But so we can see here that we're getting some access tokens back. Now, I know this kind of looks pretty scary and complicated, but that's only really because there's a bunch of long strings of text in here. And actually, when you can decipher what this means, it's fairly easy to understand that actually this is the idea of the organization, and then it's basically saying that the capabilities of this organization are able to run a deployment on your machine. Okay, you require that someone has these capabilities signed by this organization, and then this signature was actually created by the organization to allow you to verify that that is correct. And then on your side, the node will provide the capability to be able to bid on a deployment. So when it sees deployments that are sent to the network, it can bid on the deployment, or it can commit to the deployment, meaning it's actually going to run it. So what this basically means is that you will only allow someone from the organization to be able to run a deployment, and that your machine will only be allowed to bid and commit to a deployment, and not actually to be able to run a deployment on behalf of that organization. And partially the reason for that is that right now this is still very new network, and we're still in this kind of very early testing phase. So we don't want to just allow everyone to do everything and get ourselves into a situation where there's chaos on the network. We need to look to trusted organizations to work with us and to kind of work with the community and communicate with their community to kind of do stuff nicely on the network. as we start to build it and build reputation and trust among all the people that are running on the network. And that, I think, I am 1 minute over, so I am very sorry. But hopefully you got an idea of what this is about, what it takes to get connected to NuNet right now, and hopefully we can follow this up with another session where we actually start to use it. Because at the moment, all we've done is get it ready. But actually, there's some cool stuff that we can start to do with it. And I would love to kind of share with you some of the use cases that we're building and to kind of let people see how it's really being used and to get involved with it. So hopefully I'll get the chance to come and talk to you again and take it to the next level.
Yeah, for sure. Yeah, we're gonna push this sort of links and all to other people, and we'll personally guide people out. And yeah, hope they are settled with this and they can ask you for any doubts or something. And next session. So yeah.
All right. Can you guys hear me? Can you guys hear me? All right. So, first of all, I would like to say a big thank you to the NuNet team on behalf of the Ambassador Program and also AI Sandbox community. So, thank you for your valuable insights and basically educating us. And yeah, I would also love to have you guys on more of our sessions where we can look at the applications and also the use cases. So yeah, it's something that we could discuss further on, and hopefully we get to see you guys more. And also, I was also thinking about if there's kind of a feedback form, so that if members try to actually test out this application itself, if they have any issues, they could just relay that to the NuNet team. So if there's a feedback form, that would actually help. So, yeah.
Sam, you're muted. Well,
Sorry, I'm really bad at that. There's an application form at the moment to kind of join this program where by doing that you can submit your DID and then join the NuNet organization. And as part of that whole process, there's a whole kind of support process around that. I think there's a blog post. If it's not going out today, then it's going out on Monday. There's a bunch of onboarding videos that basically go through what I've just shown you here for Windows, Linux, and Mac. And as more people use it, or more people go through this install process, hopefully we'll start building a kind of a library of known issues and frequently asked questions that we can just kind of build on, and then kind of provide a reference for everyone that's kind of getting involved in the testing. And as far as kind of direct support goes, there is a forum as well as the testers chat in Discord. There's a forum in Discord, and there's also the ability to open a ticket in a Discord to kind of, if you've got direct issue where you want to talk to someone from NuNet without it being public, it will happen there.
All right, I think that's great. So thank you guys for being here. Thank you for your time, and hopefully we get to see you guys next time.